So, welcome to this session. This session we will discuss the numericals based on properties of pure substances. These numericals are from assignment number 4. Okay, so before starting this lecture, it is prerequisite that you have the basic knowledge of property of pure substances, that Ts, a curve, vapor dome, liquid vapor dome, and how we calculate dryness fraction, how we calculate specific properties such as volume, enthalpy, entropy, internal energy, and later we have calculated what sensible heat, latent heat, and enthalpy at different points. The first was in subcooled region, second was in wet region, third was in superheated region, and we calculated entropy value at 1 2 3. 1 was in subcooled region, 2.2 was in wet region, and 3 was in superheated region. So I hope that that should be clear to you. Now let's move to question number 1. These questions are very simple. You have to just understand the physics and just apply the formula. Okay, so a rigid tanks contain 10 kg of water, 10 kg of water at 90 degrees Celsius, 10 kg of water. So this is what 10 kg of water, so it is giving, okay, 10 kg of water at 90 degrees Celsius. If 8 kg of water is in liquid form and the rest in vapor form, okay, so what is the situation here, guys? So it is saying, so we have a container and we have a total, M total is 10 kg, and it is saying that mass of liquid is how much? 8 kg, okay, and the rest is vapor. So this is what mass of vapor. So I hope we can calculate from here. Mass of vapor will be 2 kg, because total mass in the rigid container is 10 kg. So we have mass of liquid at 8 kg, mass of vapor at 2 kg. Take V1 is this, so this is not V1, this is Vf, and Vg is this, the volume of the tank. This is the volume of the tank in meter cube. The volume meter cube of the tank is in. Okay, so let's try to write what we have, what data we have. So we have mass total, this is 10 kg. We have mass of liquid, that is 8 kg. Okay, and from here we know that mass total is mass of liquid plus mass of vapor. So from this relation we will get mass of vapor is 2 kg, right? And what it is given, so Vf is given, Vf is 0.0011036 meter cube per kg. Vf is this, and Vg is 2.3593 meter cube per kg. Okay, so this is what Vf, Vg. Now it is asking total volume of the tank, So guys, this is what, this is volume of the tank. So this will be what? Volume of liquid plus volume of vapor. Okay, so I think this will be in wet region. If I draw a TS curve, so you can see we have liquid and vapor. Okay, so this will be on TS curve. This region will be somewhere, see, mass of vapor is less, so this region will be somewhere here. Okay, and this will be in wet region. So total volume will be what? Vf plus Vg. Okay, now tell me how we define this Vf. We define this Vf, this is specific volume, as volume upon mass mf. So we, from here we can write Vf into mf. Okay, and from here Vg, this will be similar, Vg into mg, right? So we can write it, this will be Vf will be what? Vf into mf plus Vg into mg. I hope all values it is given in the question. So Vf, mf is how much? Mf we have calculated, mf is this mass of vapor, just write it by mf, this is mf. Okay, so mf is 2 kg, mf is 2 kg, Vf is how much? Okay, wait, mf is for liquid, mf is for liquid. Okay, so this will be 8 mf into Vf. Vf will be how much? 0.001036 plus this mg. Mg is what? Mass of vapor. This will be 2 into 2.3593. So just do this calculation. We will get volume as 4.73 meter cube. Right, so this is what? This is total volume of this container, right? So this is for question number 1. Let's move to next question. So nice. A vessel of volume 0.05 meter cube contains a mixture of saturated water and saturated steam. Okay, at temperature of 2 to 5 degrees Celsius. Okay, now let's write all the values. Volume of the vessel is 0.05 meter cube, contains a mixture of saturated water and saturated steam. Okay, so if I draw this phenomena on this physical process on TS curve, so what we were getting, right? So this was saturated liquid, this was saturated vapor or saturated steam. So this is at temperature, this is at temperature P, and it is given as T saturation, right? And temperature is given as 2 to 5 degrees Celsius. So guys, you can see that it is saying that a vessel of volume this contained a mixture of saturated water and saturated steam, right? So this is containing saturated water and saturated steam. So I hope you can understand that this point will be lie in this wet region. So at any point we will get what? saturated water plus saturated liquid in this range, right? So let's write temperature is given, mass of the liquid present is, so this line is F, this line is G, mf is 10 kg, right? Find the pressure, mass, specific volume, enthalpy, entropy, and internal energy of the mixture with the help of the table given below. Okay, so let's see what this is. Steam table. So what it gives, so this is the temperature 2250, this is temperature 2250, T saturation. Okay, at this temperature and at this pressure, these properties are given, right? In steam table we need only two variable for calculating all the properties. Okay, so here you can see that this mixture is present in the saturated region. So this P which is given here, this will be the pressure. Find the pressure. So pressure will be saturation, this will be P saturation, this will be 2.5477 MPa. Okay, now so we have all the values given here. This is Vf is for liquid, G is for what? G is for vapor or steam. So see all the values we have here. Vf we have, Vg we have, Uf, Ug, Hf, Hg, Sf, Sg, all the values we have. अच्छा यार मुझे ये बताओ कि ये सारी वैल्यूज़ तो दे रखी हैं, राइट? सो आई होप आपको वो स्टैंडर्ड फार्मूला याद होगा, हाउ वी कैलकुलेट स्पेसिफिक प्रॉपर्टीज़. दैट वाज वी एफ प्लस एक्स Vg minus Vf, and similarly was for enthalpy Hf plus X Hg minus Hf. So right, so it is very important that you have to decide what should be the proper approach for solving such questions. So you can see it is asking this specific volume, enthalpy and entropy at this region, right? So I hope all the values we have given, just we have to calculate this x that is called dryness fraction, right? So you can see that we have mass of the liquid is given as mf, okay? So from here, can I calculate volume of the liquid? Let's write it here. Volume of liquid Vf, this will be equals to what? This will be mf into specific volume. It is given in the question, right? Vf is how much? This much. So just do the calculation. This will be 10 into Vf is how much? 0.001199 meter cube. Okay, so this is what we will get, 0.03801 meter cube. Okay, so and we know that this is the total volume. This will be equals to what? Vf plus Vg. Okay, so volume of vapor कितना हो जाएगा? Volume of vapor will be, it is Vg, this will be equals to V minus Vf. V is how much? It is already given, 0.05 minus. Okay, so this is wrong, it will come here. here we will get, just multiply it at 0.01199. okay, so delete this. So we will get this value, v minus vf. V is 0.05.01199. okay, so from here we will get 0.03801 meter cube. okay, so if I want, so see, our final aim is to calculate dryness fraction. This is defined as mass of vapor upon mass of liquid plus mass of vapor. okay, so now can I get the mass of, so if we write Vg as mg into Vg. okay, so guys, do the calculation. Vg is given here, you can see Vg is given here. So from here can we calculate mg, right? From here we will get mg as 0.484 kg. okay, now we got what? mf, we got mg. now just do this calculation. mg is how much? 0.484, and mf is how much? This is mf is how much? 10 plus 0.484. so from here we will get this dryness fraction as 0.046. okay, so I hope this is correct. Now what it is asking, so we got this dryness fraction. I hope now we can easily calculate all the values. Now let me remove this section. okay, fine. Now if I want to calculate a specific volume, so this will be what? Is Vf plus x. This will be what? Vg minus Vf, right? so you just put all the values, we will get the final answer 0.00477 meter cube per kg. This is what unit for specific volume. And specific enthalpy, we will got what? Hf plus x, Hg minus Hf. put all the values. Hf is given in the question, Hf is given, Hg is given, yes, Hf is given, yes, x we already calculated. Put all the values, we will get 1051.25 kilojoule per kg. This is the unit of enthalpy. Check, this is here. Now entropy, similar, we will write Sf plus x, Sg minus Sf. so you can see this is what? This is specific entropy. so do this calculation, we will get 2.7335 kilojoule per kg Kelvin. And in this internal energy as uf plus x, ug minus uf. do this calculation, we will get 1039.14 kilojoule per kg Kelvin. okay, so this is the very simple question. So let's move for next question. So this is, find the internal energy of 2 kg of steam at 25 bar with bar when it is superheated, its temperature is being 380 degrees Celsius, it is wet, and its dryness fraction is 0.85. Okay, so let's try to calculate all the values. Internal energy, it is asking, assume superheated steam to behave as a perfect gas from the commencement of the superheating. Specific heat of the steam, this is what Cp vapor is this much. Use the following steam table. So these values we have given. So at particular pressure and temperature we have given these values. Okay, in steam table, if the two thermodynamic properties are fixed, pressure and temperature, right, or pressure or dryness fraction, we can calculate all other thermodynamic properties. Okay, now let's try to write all the information which is given in the question. So this is what mass of steam is. Mass of steam so this is F and G. So here the diagram, this is Ts. So it is asking, in first case it is superheated region, its temperature is being 380 degrees Celsius, right? Its temperature is here let's take this point as 1, and it is wet and dryness fraction is 0.85, and this is 2. Okay, this is T1, this is T2. Dryness fraction is defined at 0.2. Now let's write all the values. Mass of steam, is how much? It is 2 kg, and pressure of steam, and this is whole at pressure of 25 bar. We know 1 bar equals to 100 kPa. We will use this relation if volume is coming in the picture, and specific heat of steam, is Cp. Vapor or steam, it is taken as same here, 2.093 kilojoule per kg Kelvin. Okay, now let's try to think how we can calculate the internal energy, right? What should be the approach, right? So we have given enthalpy here, we have given volume fraction here, right? Now can you think any equation which relate enthalpy, entropy, enthalpy, internal energy, and what, volume, or any relation which relates entropy, which relates enthalpy and internal energy? So yes, we have one relation that is defined as H is equals to U plus PV. Okay, so where H is a specific enthalpy, U is a specific enthalpy, pressure, and this is what is specific volume. Okay, now if I can write this equation like this, U is equals to H minus PV. Okay, so at this point 1 I think pressure is constant, it will be 25 bar. Okay, now if I can calculate pressure, if I can calculate this enthalpy at 0.1 and volume at 0.1, then we will be able to calculate internal energy at 0.1, right? So now let's first try to find out what is enthalpy, specific enthalpy at point 1. Okay, so just you have to remember what was the formula for enthalpy. So for this I think we can write Hg plus Cp T1 minus T saturation, right? So this temperature at corresponding to this pressure we have this 223, right? T saturation, right here T saturation is given. So this is what saturation pressure and this is what saturation temperature. So T saturation is given in the table 223.99. okay, so now can we calculate the value of H1? This will be what? Hg plus Cp T1 minus T saturation. So Hg is how much? It is given here 2803.1 plus Cp is how much? Check the unit. It is all in kilojoule per kg, Kelvin. So this will be what? 2.093 into T1. T1 is how much? T1 is 380. okay, minus this will be what? T saturation is how much? 223.99. okay, so by solving this we will get 3129.63 kilojoule per kg. So this is the value of H1 enthalpy 1 at point 1. So we have found the value of this H1 and the pressure is constant. Now the challenge is how to find V1. Okay, so you can see this is lie in the superheated region, and in superheated region this vapor behaves as an ideal gas, right? So you can see from here to here pressure is constant. So if pressure is constant, can we write PV equals to mRT or can we write PV equals to RT? This is specific volume. So if pressure is constant, so can I get specific volume upon T is constant. Okay, so now let's take this point as O. okay, so can I write VO will be what? VG. V, this is for F, this is for G. So we write this VG. I am writing this point as G. VG upon T saturation equals to V1 upon T1. T1 is how much here? V1 upon T1. I think V1 we have to calculate. T1 value, is it given in the question? Yes, T1 is given as this will be VG is, let's see, VG is 0.07998. it is given here, right? And T saturation is how much? T saturation is 223.99 plus 273. okay, and here we will get V1 upon T1 is how much? T1 is 380 plus 273. Now solve this, and from here we will get V1 value, V1 as 0.1051 meter cube per kg. This is what specific volume at point 1, right? So what we have, I think we have all the values for calculating this internal energy. Now just write the equation U1 equals to H1 minus P V1. So do we have the value of H1? Yes, we have calculated here. Just put it properly 3129.63 minus 25 into pressure is how much? Pressure is 25 bar, right? This will be multiplied by 100 because this specific volume is coming into the picture, right? So this will be how much? Specific volume is 0.1051. So from here we will get this small u as 2866.91 kilojoule per kg. This is what value of internal energy at point 1. Now you can see this is what the specific internal energy, but the question is asking internal energy, that is u1 will be equals to m mass of steam. So let's take this ms into u1. So just multiply it by 2, we will get 5733.83 kilojoule. This is what internal energy at point 1. Okay, now let's try to find out internal energy at point 2. Okay, now I have to erase the section. Okay, now we have to find the internal energy at this point. Okay, now similar thing we have to do here. We have to find u2, then what we have to find h2 minus p v2. Okay, so do we have h2 वैल्यू? h2 की वैल्यू नहीं पता है, v2 की वैल्यू भी नहीं पता है. यस, प्रेशर की वैल्यू वी नो द प्रेशर वैल्यू, राइट. अच्छा, h2 कैसे निकालेंगे हम लोग? h2 निकालने के लिए आई थिंक द फार्मूला वाज for h2. Let me erase this section also. जब स्टीम वेट रीजन में रहती, हाउ वी कैलकुलेट? लेट्स राइट द इक्वेशन फॉर h2. h2 is how much? hf plus x hg minus hf. In this wet region we use this, right? So we will get h2 from here, and this volume v2, how we will find? v2 is defined vf plus x vg minus vf. Okay, so we have to use this relation, but before doing this we need the value of x from dryness fraction from the analysis, right? So we have okay fine. So I think dryness fraction is given in the question. If you see, dryness fraction is already given in the question. This is what 0.85. now अब क्या चाहिए यार? जीवन तो आसान हो गया यहाँ से, right? First calculate the h2 value. h2 will be how much? hf plus x hg minus hf. okay, hf की वैल्यू कितनी है? hf, see from this figure, this is 962.09, x is 0.85. hg minus hf is 2803. hg is, it is given here, 2803.1 minus 962.09. okay, do this, we will get h2 as 2526.95 kilojoule per kg. Okay, so this is what H2 value. Now calculate V2. V2 is how much? Vf plus X Vg minus Vf. Okay, so Vf, I think all the values we have, Vf given, Vg given, and Reynolds fraction is given. So we put all the values, we will get V2 value as 0.0682 meter cube plus kg, right? So from here U2 will be H2, we have got 2526.95 minus pressure is how much? It is in bar, convert it in kilopascal. Then V2 is how much? 0.682. It is in meter cube per kg, right? So multiply kilopascal into meter cube, we will get what? Kilojoule and per kg, right? So from here calculate the U2 value. We will get 2356.45 kilojoule per kg. Okay, and now this is what specific internal energy. Now total internal energy will be how much? Ms into U2, so multiply it by 2. Ms is given here. Okay, so we will get 4712.9 kilojoule. Okay, so you can see here the internal energy is this much, and the superheated region we got some internal energy, right? That is U1 and U2. You can compare that U2 will be U1, sorry, this is U2. You can check from your result that U1 will be very high, U1 will be higher than U2. Okay, because U1 is in superheated region, it is in vapor state. Okay, so this is all for question number 3. Now let's move to next questions. Steam span isotropically cylinder device, calculate the Reynolds fraction. Okay, so this is question number 4. Actually this is based on Rankine cycle. Describe bucket type steam calorimetry or advantage. Okay, so this question you have to do by yourself. Start the basic principle, derive this question for thermal efficiency of Rankine cycle. Yes, we will discuss this thing. I think this section is from Rankine cycle question. Okay, this is Rankine cycle, this is Rankine cycle. Okay, fine. So I think up to question 3 you will get question in your T2. Okay, and question number 4 I will upload it soon. I will upload the solution for this also. Question number 5, 6, this you have to do by yourself. Question number 7 and question number 8, these are very important for your end semester exam. Okay, fine. So this is all for today.